An elevator car whose floor to ceiling distance is equal to 2.7 meter starts ascending with constant acceleration 1.2 meter per second square. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Find the bolt's free fall time, the displacement and distance covered by bolt during the free fall in the reference frame fixed to the elevator shaft. Let's assume the upward direction as positive direction of y-axis. The distance from ceiling to floor is 2.7 meter and the acceleration with which the elevator car is ascending is 1.2 meter per second square. T equals 2 seconds after the start of motion, the bolts from ceiling starts to fall. So let's analyze the motion in the reference frame fixed to the elevator floor. At t equals 2 seconds, the velocity of bolt with respect to elevator floor will be velocity of bolt minus velocity of elevator equals 0. And acceleration of bolt with respect to elevator floor will be acceleration of bolt minus acceleration of elevator floor equals vector g minus vector w will be equal to minus 9.8 minus 1.2 meter per second square, which equals minus 11 meter per second square. The displacement from ceiling to floor in this reference frame is vector r ceiling floor equals s. And displacement, we know the formula to obtain the displacement for constant acceleration, half ab tau square equals s. So the value of tau, which is the time of free fall, will be square root of 2s divided by ab. So this will be equal to square root of 5.4 divided by 11, which equals 0.7 second. In frame fixed to elevator shaft, which is assumed as a stationary frame, let's assume the bolt's initial position at ceiling as origin yt equals 0. Initial velocity of bolt will be wt, which equals 1.2 multiplied by 2 equals 2.4 meter per second. The displacement of the bolt during this motion will be yt plus tau minus yt. So we have assumed yt as 0, so the displacement will be equal to ut. Initial velocity u is wt, so u tau minus 0.5 g tau square, which will be equal to 1.2 multiplied by 2 multiplied by 0.7 minus 5.0 multiplied by 0.7 whole square. On simplification, we will get 1.68 minus 2.45 meter equals minus 0.77 meter. So displacement will be 0.77 meter in downward direction. Time of upward motion will be equal to wt divided by g, which equals 2.4 divided by 10 equals 0.2.4 meter per second. And time during downward motion will be 0.70 minus 0.24 second equals 0.46 seconds. The distance travelled by the bolt will be equal to the sum of displacement in the upward direction and displacement travelled in downward direction. Displacement travelled in upward direction is ut minus 0.5 g t1 square and displacement travelled in downward direction is 0.5 g tau minus t1 whole square. If we sum these two expressions, we will get wt multiplied by wt divided by g minus 0.5 g wt divided by g whole square plus 0.5 g multiplied by tau minus wt divided by g whole square. If we put the values of wt and g and tau, we will get the value as 0.576 plus 5 multiplied by 0.46 whole square equals 0.288 plus 1.058 equals 1.3 meter. So the bolt travels the distance of 1.30 meter in a stationary frame. Thank you for watching this video.